Welcome to Computer Metanoia. My name is Anono Sannal and we are basically continuing our video series on digital electronics. And we are currently in the first chapter of representation of Boolean functions. So in the previous video, we have seen how to represent a binary digital system in form of a truth table. Now we will be actually trying to design the digital system from that particular truth table. So there are two approaches basically to represent a particular digital system or to design a digital system from a truth table. We have the MinTerms approach and the MaxTerms approach. The basic difference between MinTerms approach and MaxTerms approach is that suppose we have given a truth table. Fine. This is the same truth table that I derived in the previous video. I have used the same example. So we have a given truth table over here. In MinTerms approach, we are going to take those input combinations for which the output has come 1. That is the MinTerms approach. Whereas in the MaxTerms approach, we will be considering those input combinations where we have got the output as 0. In this particular video, we will be discussing only about MinTerms approach. In the next video, we will be talking about the MaxTerms approach. So in MinTerms approach, what did I say? I said that we take those input combinations for which the output has come out to be 1. Now, for 1 we see in this particular combination, we have two inputs, this and this. Two input combinations basically, this and this. That is x equals to 1, y is equals to 0, and x equals to 1 and y is equals to 1. Now, in MinTerms approach, the operation of the variable, the operation that is performed amongst the variable is the AND operation. And it is performed in such a way that if the input value is 0, then we represent it using the complemented form, and if it is a 1, then we represent it using an uncomplemented form. I'm talking about the input side, not about the output side. So for here, you see that we will perform the AND operation, and the convention that I mentioned. The convention says that, for example, in this case, 1, 0, here x equals to 1, y is equals to 0. So x is 1, that means it will be represented using an uncomplemented form. So it is x. Whereas y is equals to 0, that is y should be represented using complemented format. That means y complement. Whereas in this case, in the second case, 1 and 1, both of them are 1, so both of them, the AND operation will be performed without using any complemented form, that is simply xy. And an OR operation will be performed amongst them. So this is basically the representation of the function which is actually depicted using the MinTerms approach. That is, this is the equivalent function of this particular truth table. That means if we send any combinations of zeros and ones in this particular circuit, we'll get the desired result. For example, if you send 0 and 0, both of them are 0, then see what happens. X is 0, y is 0, y is 0, y complement becomes 1. So this particular value becomes 0. And x and y both are 0, so it will be 0. So 0 plus 0 is 0, so the output, see, it is 0. Whereas again, if both of them are 1, for which the output is 1, see, you put 1, 1, 1, this becomes 0, so this becomes 0. But 1, 1 is 1, so 0 plus 1 is 1. So you see, whatever input you provide for zeros and for x and y's, the correct output you will be getting. So this is basically the MinTerms approach. Now this representation of MinTerms can be done in many ways. And here is one of the representation which is called the MI representation. What is the MI representation? That is, we can represent this particular MinTerms function using MI representation, M suffix I, where I is basically the decimal equivalent of the input. That means if we consider this particular example where we have this particular truth table, you see, if we represent it using the decimal equivalent of the input. So you see 0 0 means 0 in decimal, 0 1 means 1, 1 0 means 2, 1 1 means 3. So this is the decimal equivalent. So see, in MinTerms, we will be considering those input combinations where the output has come out to be 1. So we have these two rows where the output has come out to be 1. That is the decimal equivalent 2 and decimal equivalent 3. So we'll be representing xy bar, which is basically 1 and 0, that will be represented as m2, m suffix 2. And this will be represented as m3 because the decimal equivalent of xy is 3, decimal equivalent of xy bar is 2. Now the other representation is this. This is the basically the first representation that has been given is basically the mi representation, that is m2 plus m3. The other representation is that we use a summation symbol, which basically means or operation. So we see we are basically performing or operation and the or of and operations. So that is why we use this or symbol, the sigma symbol. Sigma means what? In mathematically it means summation. So we are basically performing summation of all the minterms here. So summation of 2 and 3, that means the summation of the decimal equivalent 2, that is x y bar, and 3 x y, the summation of those two. Now this particular MinTerms approach is also known as sum of product form of representation. Now why it is called sum of product? Simple. The products are present and you are basically adding them up. So it is the sum of the products. So this is how we actually use the MinTerms approach to represent a particular Boolean function. In the next video, I'll be talking about the MaxTerms approach. So this is it for this particular video. Please stay tuned and watch the next video because that is in continuation of this particular video. Thank you for watching.